The core issue at stake in this research commentary is founded on the way humans have developed social and neurophysiological capacities to receive and convey information. Drawing upon history, we learn that important knowledge has been conveyed through storytelling as an inherent element of many cultures and civilizations. Human knowledge is acquired, stored, and retrieved episodically, which means in stories or through images. By nature, humans think more in narratives and pictures rather than argumentatively or paradigmatically. This means, though, that while scholarly and scientific knowledge are being produced at an increasing rate, they are unfortunately in a format that is somewhat misaligned with natural human neurophysiology. So our inability to keep up with research may not only be due to the burgeoning nature of its production, but also due to its current incompatibility with our natural capacity to consume and retain information. Now, a plethora of studies, both qualitative and quantitative, have found evidence to support the power of multimedia and video narratives as a vehicle for delivering knowledge. A video narrative is simply a story told through video, sort of like this one. In our article and this short companion video, we build upon the cognitive theory of multimedia learning, CTML, and extant studies on storytelling to theoretically and empirically make a case for video narratives as an effective means for enhancing the utility and efficacy of traditional scholarly articles. Additionally, we develop a research agenda and call on information systems researchers to lead this novel form of knowledge diffusion and to lead in the underlying research to understand how to best design and leverage these media artifacts. Throughout history, important knowledge has been conveyed through storytelling. Storytelling is an inherent element of virtually every culture. The first semiotic or symbolic representations used for recording these early stories were pictorial in form, such as cave paintings, hieroglyphs, and other pictographic languages, because these were intuitive to understand without any education or literacy. Now, the human mind naturally processes images and stories in an empathetic way, connecting the received visual information, whether explicit through pictures or latent through stories, to prior personal experiences in order to understand better the latent or explicit meanings trying to be conveyed. In fact, a large portion of the human brain is actually devoted to image processing and visual interpretation and synthesis. Additionally, visual storytelling offers a rich medium for constructing and transferring knowledge that is difficult to express in other ways, such as through argumentation. However, as a social species, we have evolved beyond simple storytelling and pictorial communication and developed the verbal portions of our brains to such a degree that virtually all emotions and intentions can be conveyed in exquisite and rich words. However, abundant research provides evidence that regardless of any individual learning style, personal experience, and a whole host of other factors, we still learn and comprehend best when information is conveyed in a multimedia format, using both verbal and visual cues, as opposed to strictly through words, whether spoken or written. This must be done strategically, however, as cognitive load theory explains that when confronted with too much sensory input, working memory becomes overloaded and some inputs are simply not processed. Importantly, another big shift in academia is that it is no longer enough to simply publish top journal articles. Increasingly, one's citations, H-index, and general research impact are critical for promotion, evaluations, and tenure. Consequently, the environment has shifted to where we must advocate for and translate our work more so than in the past. Furthermore, researchers operate in a world of extreme specialization and extreme information overload, and yet there's a great value increasingly placed on interdisciplinary work. In these settings, how can a researcher keep up on his or her own research area, let alone follow research outside his or her own immediate discipline, which is necessary to foster interdisciplinary work? Video narratives are just a piece of the puzzle, but through an empirical study, we are able to show that they are a way to increase consumption, distribution, acceptance, and citation of research. We by no means claim that video narratives will supplant the tradition of articles as a means of disseminating academic knowledge. Instead, in this essay, we advocate using video narratives to supplement the traditionally textual research articles and thus improve the dissemination of academic work in general. Now let's explore why. Let's talk about storytelling or narratives. These are a powerful mode of conveying information because they provide many touch points for the listeners to connect conveyed information with their own lived experiences. These touch points provide a quick indexing method for storing and retrieving episodic or story-based information from memory, a process that is far more powerful than storing and retrieving semantic or written information. Consider the thought experiments of Newton, Galileo, Einstein, and others. Thought experiments are a type of story for communicating complex ideas. Einstein explained the theory of special relativity by telling stories about trains, elevators, and rockets. Newton told a story about shooting a cannonball around the Earth to explain the universal law of gravity. Socrates also felt that the written word was inferior to the spoken word, and so he focused on rich storytelling to teach his pupils. Similarly, Jesus Christ told parables to the local farmers, shepherds, fishermen, and other common folk to help them understand more complex ideas, such as the kingdom of heaven. Storytelling invokes a built-in, physiological, reflexive response in the form of receiver engagement, and the human mind naturally processes images and stories in an empathetic way, connecting the received visual information to prior personal experiences in order to better understand and retain the intended message. Now let's talk about multimedia. The cognitive theory of multimedia learning is built upon dual coding theory, which identifies two primary channels for cognitive input: the visual, what we see, and the auditory, what we hear. Because we are limited in the amount of information we can simultaneously process in each channel, in order to maximize learning and reduce cognitive load, CTML recommends 5 multimedia design strategies. First, utilize both narration and animation. Second, present narration and animation simultaneously rather than successively. Third, eliminate unneeded words and sounds. Fourth, present words as audible narration rather than as visual text. And fifth, don't use captions to duplicate the narration. On top of those 5 strategies, CTML recommends 10 principles for designing multimedia instruction in order to reduce extraneous processing, manage essential processing, and foster generative processing. To these 10, we actually add an 11th, which is delivery control for managing essential processing. This table summarizes these principles. You may want to pause the video here to study the table in more depth. Now, in order to demonstrate these 11 principles, we have created a video narrative from a well-known study by Davis et al., 1989, regarding the Technology Acceptance Model, also known as TAM. A link to the video narrative of TAM is available in the description of this video. We have also provided a link to another video narrative from a recent MISQ article in order to demonstrate the benefits of a video narrative in a novel study. In making these videos, as well as the one you are currently watching, we made a conscious effort to adhere wherever possible to the 5 guidelines and 11 principles of CTML. Beyond simply theorizing about and arguing for why video narratives will enhance traditional articles, we conducted a preliminary study of 269 research-oriented academics. In order to also demonstrate that a video narrative can work for any kind of article, for our treatment material, we decided to use an incredibly more complex and less visual research article than TAM, an article recently published in JAIS. We randomly assigned participants to one of 4 treatment groups, in which they received just the video narrative, just the script from that video narrative, the full article, or both the video and the article. We found statistically significant differences between these 4 treatments with regards to perceived utility and objective comprehension. The treatment with both the video and the article was perceived to be most useful, and the article alone resulted in the lowest objective comprehension. The findings also fully support our conceptual model that the content presentation format makes a significant difference in objective comprehension and perceived utility, while perceived utility and perceived comprehension both strongly impact satisfaction, and satisfaction strongly impacts intention to cite, share, and accept the presented research. Thus, companion video narratives provide a rich and concise genre for conveying information in an engaging, relatable, and impactful way that enhances the utility and efficacy of traditional articles. The theory and supporting evidence in this paper are intended as a springboard for exploring a host of research questions around better understanding how to design companion videos and leverage them most effectively. We call on information systems scholars to lead in this research, as well as in the adoption of companion video narratives as a means for conveying scholarly knowledge.